Important question of software engineering for RGPV exam part 4. Question 8. What are the different program comprehensions? Program comprehension refers to the process of understanding and gaining insights into a software program's structure, behavior, and functionality. It involves analyzing the codebase, identifying relationships between components, and grasping the program's overall design. There are several techniques and approaches that aid in program comprehension. Here are some of the different program comprehension techniques. 1. Code reading. Code reading is the process of carefully examining the source code to understand its logic and flow. It involves reading and analyzing the code line by line, understanding variable assignments, control structures, and function calls. 2. Code navigation. Code navigation techniques allow developers to quickly move through the codebase to locate specific sections or modules of interest. This can include using AICTE features like search functions, code navigation tools, or bookmarks. 3. Code visualization. Code visualization techniques present the codebase in a graphical or diagrammatic format, making it easier to understand the relationships between components. This can include techniques such as class diagrams, sequence diagrams, or dependency graphs. 4. Documentation analysis. Analyzing documentation, such as design documents, requirements documents, or comments within the code, can provide valuable insights into the program's intended functionality and design decisions. 5. Dynamic analysis. Dynamic analysis involves running the program and observing its behavior during execution. This can include techniques like debugging, tracing, or logging to understand how the program interacts with data and processes. 6. Reverse engineering. Reverse engineering techniques involve analyzing the code and software artifacts to gain insights into the program's structure, algorithms, and dependencies. This can be particularly useful when documentation is incomplete or unavailable. 7. Program slicing. Program slicing techniques focus on isolating specific portions of the code that are relevant to a particular functionality or behavior. This helps in narrowing down the analysis to specific sections and understanding the code's impact on a given feature. 8. Conceptual modeling. Conceptual modeling involves creating higher-level abstractions or representations of the program's structure and behavior. This can include creating architectural diagrams, state diagrams, or other visual representations that simplify the understanding of complex systems. 9. Collaborative approaches. Collaborative approaches involve discussions and interactions with other developers or stakeholders who have knowledge about the program. Collaborative techniques such as pair programming, code reviews, or knowledge-sharing sessions can provide different perspectives and enhance program comprehension. It's important to note that program comprehension techniques are not mutually exclusive, and different techniques may be combined or used in conjunction to gain a deeper understanding of the software. The choice of techniques depends on the specific context, complexity of the program, available resources, and the goals of the comprehension process. Question 9. How software requirement specifications are used in the development of the software? Write the characteristics for the software requirements specification. Software requirements specifications, SRS, play a crucial role in the development of software as they serve as a foundation for the entire development process. Here's how SRS is used in software development and some key characteristics of a good SRS. 1. Communication and understanding. SRS acts as a communication bridge between stakeholders, including clients, users, and development teams. It helps to ensure a common understanding of the software requirements and serves as a reference throughout the development process. 2. Basis for design and development. SRS provides a comprehensive and detailed description of the software requirements, including functional and non-functional requirements, user interactions, system behavior, and performance expectations. It serves as the basis for designing and developing the software system. 3. Requirement traceability. SRS establishes a traceability matrix that links the requirements to various design elements, modules, and test cases. This helps ensure that all requirements are adequately addressed and tested during the development process. 4. Risk management. SRS identifies and defines the potential risks and constraints associated with the software project. It helps in mitigating risks by considering security, scalability, performance, and regulatory compliance aspects from the early stages of development. 5. Change management. SRS serves as a reference document for managing change requests during the development process. It provides a clear baseline for evaluating the impact of proposed changes and assists in maintaining the integrity and consistency of the software requirements. 6. Validation and verification. SRS is used as a basis for validating and verifying the developed software system. By comparing the implemented software with the specified requirements, it helps ensure that the final product meets the intended functionality and quality standards. Characteristics of a good software requirements specification. 1. Complete. The SRS should capture all the necessary requirements and details of the software system, leaving no ambiguity or room for interpretation. 2. Clear and concise. The requirements should be presented in a clear and concise manner, using simple and understandable language to avoid misunderstandings. 3. Consistent. The SRS should maintain consistency throughout, ensuring that requirements do not contradict or conflict with each other. 4. Measurable. Requirements should be specific, measurable, and verifiable, allowing for objective evaluation of whether they have been met. 5. Testable. The SRS should provide a basis for designing test cases and validating the software system against the specified requirements. 6. Traceable. Each requirement in the SRS should be traceable to its origin and linked to relevant design elements, enabling traceability and impact analysis. 7. Feasible. The requirements should be technically feasible and within the constraints of the project's resources, budget, and time. 8. Understandable. The SRS should be easily understandable by all stakeholders, including clients, developers, testers, and users, to facilitate effective communication. By adhering to these characteristics, the SRS serves as a reliable and comprehensive document that guides the development process, ensures alignment with stakeholders' expectations, and contributes to the successful delivery of a quality software product. Short notes. A. Requirement validation. Requirement validation is the process of ensuring that the software requirements are complete, consistent, and aligned with the stakeholders' needs. It involves reviewing, analyzing, and verifying the requirements to identify any gaps, conflicts, ambiguities, or errors. The goal of requirement validation is to eliminate misunderstandings and ensure that the requirements accurately capture the desired functionality and behavior of the software system. Techniques used in requirement validation include reviews, walkthroughs, inspections, and prototyping. By validating requirements, organizations can minimize the risk of developing software that does not meet user expectations and improve the overall quality of the software product. B. Dynamic analysis. Dynamic analysis is a technique used in software testing and debugging to analyze the behavior of the software during runtime. It involves observing the execution of the software, capturing runtime data, and analyzing it to gain insights into the program's performance, correctness, and efficiency. Dynamic analysis techniques can include profiling, code coverage analysis, memory usage analysis, and runtime error detection. By performing dynamic analysis, developers can identify bottlenecks, memory leaks, performance issues, and other runtime problems in the software. This information helps in optimizing the software, improving its reliability, and enhancing the overall user experience. C. Software quality assurance. Software quality assurance, SQA, is a set of activities and processes designed to ensure that software products and development processes adhere to quality standards and meet the desired level of quality. SQA involves defining and implementing quality processes, establishing quality metrics and goals, and monitoring and evaluating the software development activities to ensure compliance. It encompasses activities such as quality planning, quality control, and quality improvement. The key objectives of SQA include preventing defects, identifying and resolving issues early in the development lifecycle, and continuously improving the software development process. SQA techniques include reviews, audits, process documentation, quality metrics tracking, and the establishment of quality management frameworks like ISO 9000 or CMMI. By implementing effective SQA practices, organizations can enhance customer satisfaction, reduce rework, and deliver high-quality software products.